So we're asked which table gives three values of x and their corresponding values of q of x for the given function. Now it's worth, before we start, probably reviewing just a couple of things. We'll remember in function notation, that is the same thing as writing y is equal to 32 times 2 of x. Those two things are the same thing. And when we're in function notation, anytime we replace this x, we have to replace this x with exactly the same thing. They are the same x. So we have to select one of our three values, -1, 0, or 1, and just calculate it and see what we get. And it's going to align to one or two of the answers. And I'm going to select 0 to start with, just because 0 is an easy number to do calculations with. And so to calculate that number, we're just going to take q of 0. That's going to be equal to 32 times 2 raised to the 0 power. And again, I replaced x with 0 here. I have to replace x with 0 here. Now at this point, it might be worth reviewing an exponent rule. An exponent rule, it says anytime we raise something to the 0 power, it is equal to 1. Doesn't matter what it is. If it's a variable we're raising to the 0 power, that's going to be 1. If it's some sort of random number we're raising to the 0 power, that's going to end up being 1. And so in our example, we have 32 times 2 raised to the 0 power, which is 1, which gives us a result of 32. Now we can see for letter A that q of 0 equals 0. That's incorrect. For letter B, q of 0 equals 2. That's incorrect. For letter C, q of 0 is 32, so that could be correct, but we get the same result in letter D. So we're not sure. We know it's not B and it's not A, but we're not sure between C and D. And so what we have to do now is test another number. It wouldn't make any sense to test q of 1 because those come out with the same result. So we're going to test q of -1 and see what we get. Now when I test q of -1, I end up with 32 times 2 raised to the power of -1. And again, just to emphasize, I replace the x here, I have to replace the x here. And we'll remember another exponent rule, which says when I raise something to a negative power, it just ends up forming a reciprocal. A to the -1 equals 1 over a. If, for example, I were to see x to the -2, that's nothing more than 1 over x squared. So in our example, we have 32 times, well, 2 to the -1 is 1 over 2. 32 times 1/2 is 16. So in letter C, q of -1 gave an output of 1/16, which is incorrect. In letter D, -1 gave an output of 16, which matches our output, which means letter D has to be the correct answer. Appreciate any thoughts or comments you have on that one. Keep practicing. I'll see you in the next one.